Here we're going to discuss parabolas and what's called the vertex formula. So I've graphed a few parabolas here, and these two parabolas are what we say opening upwards, and this parabola is opening downwards. Now, there are a few things to point out about parabolas. The first is that they have a high degree of symmetry. And what I mean by that is if I draw a vertical line like this, I can see that this branch, as we say, looks exactly like that branch. That is, these are mere reflections across what's called the axis of symmetry. And I can also draw an axis of symmetry here. That is a vertical line and a vertical line here. Let's go ahead and do that. Let's draw in the axes of symmetry for these parabolas. In all three cases, the axis of symmetry is a vertical line. Like this vertical line might have the equation, for example, x is equal to -3. And this one might have the equation x is equal to +1. And this one might have the equation x is equal to 4. Notice that these are equations of vertical lines. The axis of symmetry is, it's not actually on the curve. The curve here, the parabola, is a set of points, and the axis of symmetry is usually drawn in dashed to indicate the symmetrical relationships between the two branches, but it itself is not on the parabola. A few other things to point out. Every parabola has a y-intercept. Like, for example, this parabola intersects the y-axis right here. This would be its y-intercept. And the y-intercept for this parabola, well, you'd have to keep extending this branch and eventually cross the y-axis way up here. And likewise, this parabola would cross the y-axis up there. Every parabola has a y-intercept. Now, as far as x-intercepts are concerned, sometimes parabolas have them, sometimes they don't. Like this parabola has two x-intercepts, one right here and one right there, right? This parabola over here has one x-intercept right there. And this parabola has no x-intercepts. It never crosses the x-axis. Let's write that down. So as far as x-intercepts are concerned, parabolas can have 0, no x-intercepts, 1 x-intercept, or 2. And those are the only possibilities. There's yet another point that's important when graphing parabolas, and that's called the vertex. The vertex is either the high point or the low point of the parabola, depending upon if it opens up or down. So this parabola opens up, and right here, this point, the low point, would be it's called the vertex. And the vertex is a point, so it actually has an x-coordinate and a y-coordinate. And likewise, this would be the vertex for this parabola, right? In this case, it's a high point because the parabola is opening downward. And again, it has an x-coordinate and a y-coordinate. And this would be the vertex of this third parabola. Now, it turns out that there's a formula that we can use to find the x-coordinate of the vertex. And let's see what that is now. So to find the x-coordinate of the vertex, we use the formula x is equal to -b over 2a. Okay, so the first thing you have to do is take your parabola. Now this is an example of a quadratic function, and a quadratic function in one variable, the graph, is a parabola, as we'll see. So for right now, we're just sort of trusting that that is the case. And what you want to do is first write your quadratic function or your parabola in standard form. Now standard form is this. It's ax squared plus bx plus c. Okay, and I can see that this is written in standard form already. Now, when I look for a, b, and c are the relative coefficients. So for this one, I see that a is equal to 1, right? 1x squared. B is -6. And c would be -7. Okay, once you identify your a, b, and c, you make use of the vertex formula. So we make use of the fact that the x-coordinate is b in the numerator, and b is -6 over 2 times a, right? Over 2 times a, and a is 1. So it's this. So x is going to be, let's see, -6 over 2 is -3. So the x-coordinate is +3. Now that's not the vertex, that's only the x-coordinate of the vertex. To find the y-coordinate, we're going to plug the x in, we're going to plug 3 in for x. So f of 3, right, to find the y-coordinate of the vertex, that's going to be 3 squared minus 6 times 3 minus 7. So it's going to be 9 minus 18 minus 7, which is -9 minus 7, which is -16. So the vertex has coordinates, right? The point, the vertex, has coordinates 3, negative 16, and that would be our answer. Now you might ask yourself, well, why does this formula work? Why is that the formula for the x-coordinate of the vertex? And let's go ahead and try to answer that question now. So the question is, why is the vertex formula x equals negative b over 2a? So we're first going to start with an observation. Here I have a number line, and if I had the number 5, for example, let's say I subtracted 3 from 5, and that brought me to this point over here, 5 minus 3. Now I know that's 2, but I'm just writing it this way to illustrate a point. So if I subtract 3, I'm over here at this point. But if I go back to 5 and I add 3, I'm over here, right? I'm at 5 plus 3. And the point is that what I get over here when I add 3, right, at this point, it's equidistant from 5 as this point is. In other words, 5 is in the middle. It's right in between, halfway in between 5 minus 3 and 5 plus 3. Now, it also is true, it goes the other way, that if you have two numbers written in this form, you can make a conclusion about what's in the middle or between them. So for example, if I saw I had, 7 minus 4 and 7 plus 4, I draw the conclusion, of course, that 7 lies halfway between these two numbers, because I can just observe that I've taken 7 and subtracted something, and then taken the same 7 and added something. So these numbers are going to be on opposite, or both, as far equidistant from what I started with, in this case the 7. And likewise, if you had negative 2 minus 10 and negative 2 plus 10, right, that these numbers are going to be equidistant from negative 2, which is going to be halfway between those two numbers, right? Because I'm taking negative 2 and subtracting and then adding the same number. Now, the reason that's relevant is because when you graph a parabola, what we're going to be doing is we're going to be looking for x-intercepts. So this would be an x-intercept, and this would be an x-intercept. And when you do that, you can make use of what's called the quadratic formula. And we're going to see what this is in a later video. But the quadratic formula, for now, well, in the future as well, it's going to be this. It's negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Now, do you see the little plus and minus here? What we can do is we can break this up. So I'm going to write negative b minus all this over 2a and negative b plus that over 2a. So let's write that in the following way. So first I've got negative b over 2a, and then I've got minus that, right? So minus square root of b squared minus 4ac over 2a. That's making use of the negative in the middle here and also splitting those. And the other one's going to be this. It's going to be x is equal to, well, negative b over 2a, right? I've got this part, negative b over 2a, but then plus all of that over this. So plus the square root of b squared minus 4ac over 2a. And the reason I wrote it like that, even though we're never going to write it like this, the reason I'm doing it now is because look at the form that it has. I see that I've got something minus something else, and then something, the same something, plus something else. And that's like this, right? It's negative 2 minus 10 and negative 2 plus 10. It's negative b over 2a take away something, and negative b over 2a plus something. And for the moment, let's pretend that a was positive. Now, if a was positive, then all of this would correspond to that right there, that x-intercept. And all of this would correspond to this x-intercept. But you know from this discussion up here that in this case, negative 2 was between those two numbers, right? In this case, it's not negative 2, but it's negative b over 2a. So negative b over 2a, because you're subtracting something and adding something, would lie between these x-intercepts. Now, if it lies between those two, then it must lie right here on the axis of symmetry. And that means that the equation of this line, right, because this is the x-coordinate, the equation of this line is x equals negative b over 2a. That means every point on this line has a value, an x-coordinate of negative b over 2a. But of course, the vertex lies on the axis of symmetry. And that's why the x-coordinate of the vertex is negative b over 2a. It's actually, you can see that result because it's this part of the quadratic formula. Okay, and that's not a coincidence, right? Because to find the x-intercepts, you subtract and add the same quantity, which means negative b over 2a is going to be halfway in between the intercepts, and therefore we'll give you the negative b over 2a will be the x coordinate of the vertex. Okay, until next time.